Good morning students. I am Abhishek Nanda. I am from the educator team. Today we will discuss about acid, base and salt. So let's start. What is an acid? There is a pH for every solution. It decides its acidic or acidicity. What is acidicity? A solution, either it is acid or it is base, or it has some properties of acidic nature or basic nature that we can identify from the pH. So the acids that have the pH less than 7, we call them as acid. Which are small less than 7, we call them weak acid, and there are a large small than 7, we call them strong acid. Like a acid having a pH of 2 will call be a strong acid. Then it neutralizes the bases. Yes, we know about the positive and negative. Likewise, there is acid and base. If they meet with each other, if they pour with each other, they neutralizes themselves. The acids that forms H plus ions. Yes, H plus ions means in the solution it always come up with an H plus ion, which is otherwise called as hydrogen ion. Sometimes it come with the water base and it create hydronium ions. Next, the acid is the corrosive reacts with most metals from a hydrogen gas. Yes, the acid it reacts with the metals and came up with the hydrogen gas. The acids are good conductors of electricity. Acids generate ions. Yes, we knew about that the acid that forms the H plus ion, but here is not H plus, here it is H3O plus. So why it is? Sometimes the H plus ion is combined with water because the reaction came up in an water solution. So the H plus ion mixed with the water solution come up with H3O plus ion. We called it hydronium ion. We call H plus as hydrogen ion. So here is a reaction that HNO3 plus H2O is giving rise to the H3O plus ion plus NO3. We already talked about this. There are some strong acids and some weak acids. Like some acids that completely give up their H plus ion. Like when HCl will react with NaOH, the HCl gives completely its H plus ions. But in some cases it doesn't happen. Some acids are not that capable that they can give up all their hydrogen atoms and completely neutralize. So when the neutralization process is complete and the acid give all its H plus ions, they are called strong acids. But sometimes when it didn't happen, that is called as weak acid. They cannot give all of their H plus ions but some of their H plus ions. So there are some weak acids and some strong acids. Some weak acids are acetic acid, boric acid, nitrous acid, phosphoric acid, sulfuric acid. And some strong acids we already know about that, like hydrochloric acid. We knew about that in the digestive system. And some are nitric acid, sulfuric acid, hydrochloric acid. Yes, this is the acid, the common acids we already know. We always come up with these acids like HCl, hydrochloric acid. We already read about it in digestive system. Yes or no? Then sulfuric acid. What is the work of sulfuric acid? It is used in car batteries and the inverter batteries. Like next is HNO3. It is nitric acid. We use nitric acid in explosives. Then Hc2H3, that is the acetic acid. We use vinegar to make our food tasty. So in vinegar we had acetic acid. H2CO3, carbonic acid. We drink the thumbs up, Pepsi, the sodas, they have carbonic acid. Then H3PO4, phosphoric acid. We used the phosphoric acid for flavoring our food. Now I will ask you some questions like why we cannot store the acidic food products like curd in the copper vessels. Why? Just think about it. Okay, I will tell you. Because the acid have a tendency to react with the metals, and copper is a metal and the curd is a acidic product. So the acidic product that is in curd that develops a reaction with the copper vessel, and it makes hydrogen gas and makes the curd unhealthy for us. The second question, why the we have a concept that there are some indicators that from which we can know that this is a acid or this is a base. So a HCl, that is a dry HCl, can call from the indicator that it is not acid. Why? Because to change the color of the litmus paper or any indicator, we have to have the ions, that is acid from H plus and OH minus from the bases. Still, as it is not there in dry hydrochloric acid, we cannot form any H plus ion, so it will be not change the color of the indicator. What is a base? Like I said, we all know what is a acid. Like the positive and the negative charge, we already discussed about it, that is a acid and a base. So the opposite of acid means the pH of which solution are greater than 7 are called as base. They feel slippery. Slippery means they feel soapy in the hands. We also use soap in our hands. Soap is also a base. It dissolves the fats and the oils. Yes, it dissolves the fats and the oils. The base, when it comes for reaction, it gives out the OH minus ions. Like H plus ions in acid, we have here OH minus ions in bases. The same thing as the acid neutralizes the bases also neutralize the acid. There are also some strong bases and some weak bases. Like I said, the base also, some of the base completely give over their OH minus. They are considered as strong bases, and some of them did not give all of their atoms but some of their atoms. They will call as weak bases. So some name of the weak bases are ammonia, potassium carbonate, sodium carbonate, etc. Some name of the strong bases are sodium hydroxide, sodium phosphate, barium hydroxide, calcium hydroxide, etc. Then we knew about some common bases, that is NaOH, sodium hydroxide. What do we do with that? It is used in soaps, the cleaners. Then magnesium hydroxide, MgOH2, it is used as antacids. Then aluminum hydroxide, AlOH3, that is we use them with antacids and deodorants. Then NH4OH, that is ammonium hydroxide, that is called as ammonia. We use it as ammonia. There are some acids or bases typically when we are in 80s, then we do not come across the developments. So how we call the acids and the bases by the Arrhenius method, or the Arrhenius or the Steven Arrhenius, who developed the concept of acid and bases. He has some different point of view, like the acids that produces hydrogen ions in water. But later we know that the acids do not produce hydrogen ions. They gave off their hydrogens in the water. Like there are Arrhenius base that produce hydroxide ions in the water. This is the Bronsted-Lowry acid, that is, when a hydrogen gives out its ion or H plus ion, then it is called as a reaction. Then it is create a reaction. It is called as Bronsted-Lowry acid. And when the product that is accept a hydrogen or H plus ion in a reaction, that is called as Bronsted-Lowry base. Then we will discuss about the pH scale. What is a pH scale? Yes, the pH scale is there to identify the acidity or the basic nature of different substances. Like the lemon juice. The lemon juice have the pH of 2.0. It means it is acidic in nature, and it is this much lower, means it is a highly acidic. Then wine of pH 4.0. Then the rainwater of pH 5.5. The human blood of pH 7.5. It is more than 7. It means it is a basic in nature. Then baking soda, it is have pH of 8.5. Deodorant having pH of 10.0. Bleach having pH of 12.5. Here we can know the pH of different substances, like the hydrochloric acid, it has 0 pH. Gastric acid have 1.6 pH. Lemon juice having 2.2. Vinegar having 2.8. Carbonated beverage, that is 3.0. Orange, that is 3.5. Apple juice, that is 3.8. Tomato, it is 4.2. Coffee, it is 5.0. Soil, it's 5.5. Bread, it also 5.5. Potato, it has 5.8. Urine, it has 6.0, and milk, it has 6.4. So this means this much products are acidic in nature. Then after 7 we discuss water. It has 7.0. Drinking water, it has 7.2. Blood, it has 7.4. Deodorants, it has 8.0. Bile, it has 8.0. Sea water, it has 8.5. Milk of magnesia, it has 10.5. Ammonia, it has 11. Bleach, it has 12. And NaOH like solutions, it has 14. So these are basic in nature. So there are some acidic and basic substances by the pH scale. Now there are some indicators. The indicators we use to identify the substance as acidic or basic in nature. Like the first indicator is phenolphthalein. It is faint pink in color, but when it come across an acid, it became colorless. When it come across a base, it became dark pink. Bromothylmol blue, it is green in nature, but when it come across the acid, it becomes yellow in color, and when it come across the base, it is blue in color. Then litmus paper, it is neutrally the red color, that the blue color that gives red color by the acid, and the red color paper given blue color by the base. Means when a red color come across a acid, it will not change its color, and a blue color when comes the base, it will not change its color. Then pH paper. pH paper is a indicator we already discussed about to have specific value of pH that declares the substance as acidic or basic in nature. There are some buffers. We use some solutions as buffer to resist the changes in pH while small amount of acids and bases are added. Like some rainwater having acidic components, means it is acidic in nature. So we can add some buffer to change the pH to 7. Then we can use it as normal water. See some situation in which pH is controlled, like heartburn. When for the acidic nature our heart burns, so we use antacid to maintain the pH. Planting vegetable and flowers, fishing tanks and ponds, bloods and swimming pools. There are some reaction like HCl plus H2O. It gives H3O plus Cl minus. So here the hydrochloric acid, the combining with water, they can give a H3O plus, means hydrogenium plus atom, and a Cl minus atom. Like there is NOH also in water. The NOH gives N plus ion and OH minus ion. Then the NaCl of the NaOH water and the Cl of the HCl, they combine to form NaCl, and the H from the acidic solution and the OH from the NaOH base, we can get HOH, that is S2O. This is why we form the HCl is a acid, the NaOH is a base. By combining both, we can form NaOH, that is a salt, and S2O, that is water. Then acid rains. Some pollutants like sulfur dioxide, carbon dioxide, nitrogen dioxide, they get into the air, then pollute the air. And when the rain occurs with the water particles, it mixes and combines the products like sulfuric acid and carbonic acid and drops down with the water. It is called as acid rain. How the acid rain occur? The sulfur dioxide and nitrogen dioxide gets released by the factories, different types of factories, and they go to the atmosphere. They react with the water vapor present in the atmosphere, and they form the acid like sulfuric acid and nitric acid, and the acid drops down with the rain, causing acid rain. It has various, as we said, the rapid changes in the pH also can kill fish and other organisms in lakes and streams. So the pH of a substance should be maintained, like a pH of a pond or a water stream should be maintained, or it will be not able, or a fish or the other aquatic animals will not able to live in the stream. Like the soil pH is affected and kill the plants and create sinkholes. There are some effects of acid rain, like when the acid rain occurs and it mixes with the pond water, then it will be acidic in nature. So the fish cannot survive there, they were dead. Now the plants, some plants will be acidic in nature by the acid rain and they cannot survive. The monuments like Taj Mahal, they become yellowish by the reaction of water, so the acid rain with the marble. Okay, now some questions for you, like how we use the antacid tablet when we have an acid problem? Because the acid problems is there in our stomach because of the increasing amount of acid produced. So to minimize the effect of the acid in our stomach, we use antacid because that is the base and it can minimize the acidity of the stomach. The second question, when we are bitten by a bee, so we use chalk there to relieve the pain. How? Because the bee that bee bite us has given up a acid there. So neutralize that acid, we have to add a base there. So chalk is a base, so we use chalk at the place of pain. What is a salt? A salt is a neutral substance produced from the reaction of an acid and a base. So we already discussed about it, how the hydrochloric acid and a NaOH substance mix with each other and gives out the sodium chloride, that is NaCl, and water. It composed of the negative ions of the acid and positive ions of a base. One of the products is called neutralization. Like we called about the charge, the positive and the negative, they became neutralize each other. Likewise, the acid and the base that mixes and neutralize each other. We call this reaction as neutralized reaction or the neutralization reaction. Example, KCl, MgSO4, Na3PO4. This is how a neutralization reaction occurs. A neutralization reaction of an acid and a base, like the H2SO4 and NaOH becomes NaHSO4 and H2O. H2SO4 which is a acid and NaOH which is a base. By intermixing with each other, they form a salt, that is NaHSO4, and H2O, that is water. We know that the pH helps us in digestion. Like we know about the hydrochloric acid in our stomach, and when it is occurs in much more way, we use antacid. So like the digestion process by which foods are broken down into simpler substance, we already know about it. There are some mechanical processes and some chemical processes. So the chemical digestion includes chemical reaction that has large molecule to break down into small molecule. Yes, sir. The pH in different parts of the digestive system. The pH of the mouth is 7. The saliva contains amylase, an enzyme that begins to break carbohydrate into sugars. Stomach, the pH of stomach is around 2. Protein broken down into amino acids by the enzyme pepsin. In the small intestine, the pH is around 8. Most of the digestion ends here. Small molecules move to the bloodstream towards the cell that use them. Thank you for listening us. The last question, that the hydrochloric acid that is in our stomach, which is a reactive acid, and the NaOH, which is a reactive base. By concluding both of them, we get NaCl, that is sodium chloride, that is the salt we eat in our everyday life. For more educative videos, subscribe to our channel. Thank you.